Hi, Year 12 Extension 2. We're going to look at the same question now, but just expanding the sigma notation as an alternative way of working out the question we did earlier. So, same question and same beginning. So, you've got to start off with n equals 1. Okay, n equals 1. That means on the left-hand side, you'll have 1 over 3 by 1, which is equal to a third. And then on the right-hand side, you'll have 1 over 3 as well. So left-hand side equals right-hand side implies true for n equals 1. Okay, next step, suppose true for n equals k. Okay, so there are 4. So start off with 1 over 3. Yep, 1 over 3, and then plus 1 over, okay, next value you're going to put is 2, so if we put 2 in here, you get 5. That's 3 times 1 there, so you're going to get 5. And then over here, if you put 2 in here, you're going to get 3. 5 times 3. Then put 3 in here, you're going to get 7. And you put 3 in here, you're going to get 5. Okay, so you can see that pattern keeps going. And 1 over 2k plus 1 outside of 2k minus 1 is equal to k over 2k plus 1. Will do. All right, now we've got to prove true. So prove true for n equals k plus 1. So that means you've got to prove that, or required to prove that 1 over 3 times 1 plus 1 over 5 times 3 plus 1 over 7 times 5, dot, 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 plus, and you write out the whole expression again, 2k plus 1, 2k minus 1. Now, you've got to add in the k plus 1 term here. So I'll need the whole bit. So that'll be 2 outside of k plus 1 plus 1, square bracket. And then, let's see if I can fit this in, 2 outside of k plus 1, and then minus 1, close bracket, equal to, now we've got to put the k plus 1 in there, so k plus 1 over 2 outside of k plus 1 plus 1. So, in other words, required to prove that 1 over 3 times 1 plus 1 over 5 times 3 plus 1 over 7 times 5 plus dot, 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 plus 1 over 2k plus 1 2k minus 1 plus, now we're just going to tidy up that last term there. So we're going to get 2k plus 2, 2k plus 3 there. And then 2k plus 1 here equal to k plus 1 over 2k plus 3. Okay, so that's the required to prove part. And obviously we're going to start with the left-hand side. Okay, so let's just put that up, put that up there, and then come back down. Okay, so we've got the left-hand side. All right, now let me just move that down a bit. There we go, there's the left-hand side. Okay, now we're going to replace this bit here and this bit here with our assumption. Okay, so left-hand side becomes k over 2k plus 1 plus 1 over 2k plus 3 and then over 2k plus 1. Okay, I can get that out of the way now. All right, so that gives you, now we've got to create the common denominator again. So over here, I'm just going to put 2k plus 3 and then obviously 2k plus 3 there as well. So it gives me now, as a common denominator, I've got 2k plus 3, 2k plus 1, and then we've got k times 2k plus 3 plus 1. Okay, so let's expand the brackets. You're going to get 2k squared plus 3k plus 1 over 2k plus 3, 2k plus 1. Okay, so that is equal to, well, let's expand, factorise, plus 1 all over 2k plus 3, 2k plus 1. Okay, so that cancels with that, and you're left with k plus 1 over 2k plus 3, which equals the right-hand side. Okay, and that's finished. So therefore, true for n equals k plus 1 if true for n equals k, since true for n equals 1, the formula holds for all positive integers n greater than or equal to 1. Done. So you can see the advantages and disadvantages for this method. One of the disadvantages is it takes more working out.